Now, my talk will be about open data, open geodata, with a perspective on future applications. Internet of Things. That's just one buzzword as an example.
Sorry?
Okay, back again.
Does it work?
No, because it's out here.
We should wait until the computer recognizes it. So let me say and we'll
Okay.
Okay.
So why this? At my institute, 35 research fellows, we're doing research in two domains. On the one hand side, computing, so it's about the design of hardware and its application in different domains. And on the other hand side, geomatics or spatial computing. We have a lot of computer scientists also in this group. And I would start with some criticism on our current understanding of open geodata in general. Because from my perspective, there is at the moment a change in how we handle data, what kind of data we are acting. If we look at the current definitions we have for geodata, just some examples, they are all quite similar. Then we talk about geographically referenced data, geospatial data, which is described by location and the characteristics, attributes of some spatial features. They are almost all the same, these descriptions. And if you look at it, they all refer to data. They all refer to geo-reference data, the spatial characteristics, and they're always talking about landscape. Let's have a closer look. 3 critics. The first thing is about the understanding what is geo-reference data. What quality of geo-reference is necessary that reference data gets geodata. Second, the understanding of the underlying object. Which features can be represented as geodata. And third criticism, the understanding of data in general. Just look at the text again, because this has consequences of what our understanding of open geodata is. First, with regard to the references. We see here in the first definition, it's about both location plus the characteristics, the attributes of the feature. Which means the geospatial reference needs always to be stored with the data that it becomes geodata. From my perspective, a little bit weird. I'll tell you later why. Then about the objects we are talking, objects of the landscape. We are doing a lot of fleet measurements, for instance, for BMW or Audi. I have never heard that a car is part of the landscape. But from us, it's geospatial data. When it moves, where it stands, where it is. And then here, one of the most important German geoinformation scientists talks about data elements. As a computer scientist, I don't know any data elements. What is a data element? I know about data, but I don't know about data elements. And if you look a little bit deeper at the understanding of geodata, then quite often it appears that geodata is picked from its form, how it is stored. It's not about the data, it's about the form, how it's stored. If I would ask geoscientists what is geodata, they would say it's some data that is stored in files like KML or shape, or best case, it's something, an entry in a database. That's the understanding, a naive understanding, how I have called it. Naive understanding in practice. Now the reasoning, from my position, why we have a problem with these definitions of geodata, or transferred later on to open geodata. Where Bill comes from, this German geoscientist, is this domain where we have the geoinformation specialist sitting in front of his PC working with geodata. The new paradigms are different. We have embedded computing. We collect data through mobile devices, which are integrated in machines, equipments, whatever, cars. We have these big buzzwords, I don't like them, but they are a little bit transparent to give an understanding where I would like to guide you. We are talking about pervasive computing and ubiquitous computing, which means computing enters every domain, every device. Computing cannot be only done on a PC, on a computer, it can be done in every kind of machinery, equipment, thing. We have smart user devices. That's not only a smartphone, this can be a car, it's also a smart user device. We have crowdsourced data that we get out of these devices here. And we have this big buzzword all around it, Internet of Things, that everything can be connected to the internet and contribute to collecting data. And if you talk about things, they are distributed, spatial, which means they collect geodata, is this correct? But they're not part of the landscape. And we have some other domains where geoinformatics appears, pops up, like Industry 4.0, intelligent machinery that is spatially distributed in different plants. Now you can say, okay, it's industry, it's not geoinformatics, but spatially distributed machinery, it makes a reason why a machine is there and not in another place. From a logic perspective, this makes it geodata, which means we can apply our technologies. Or autonomous systems, like autonomous cars. Moving objects, moving in space, not part of the landscape, but something like geodata, it sounds like it. And if you look at the change we are facing, that we get as geoinformation scientists, here from the presentation-centric approach to a data-centric approach. In this case, I had the specialist sitting in front of his computer, watching at the data, looking at it. It was a map perspective. The data was presented. In this case, we look at a lot of applications where nobody will see the geodata. It will be processed. The spatial reference will be used for some calculations, improvements, algorithms, but nobody will see the data. Just think about search algorithms behind Google, spatial search. You enter at home for the next pizzeria in the search field, and there will not be the best pizzeria, but there will be the best next to you. You will never see the map. You will see the result. But the geodata behind is used in any case, in any way. And the second is we get a change from a user-centric system, the user with its map system where data is represented, into a system-centric approach, where in car tracking, fleet management, nobody will see the data, geodata, get a map, but will immediately get an SMS if the car gets stolen. Geodata is used but not presented. And if you look at the domains where we apply and handle geodata, we are working with moving objects, so it's not the landscape, it's about devices. We are gathering data through sensor systems. There's nothing like somebody walking out there in the landscape doing some surveying. We have automated sensor systems delivering huge amounts of data. I avoided here the word big data, but it would be behind data analytics. We do not present the data, we calculate on basis of it. It's about statistics and algorithms and not about map representation. We use different kinds of technologies like RFID to tag objects as spatial references, spatial marks. We use signals. I'll give some examples on this. Signal data. And at the end, thinking about the file thing, we also work on data streams. We just get the data rushing through and we pick the data out we need out of the stream. We never store it. It's just analyzing the stream. Data comes from somewhere and then it gets rid. It's away. And we pick only the data we need. So it's not a file-based approach. With regard to the reference, then the classical process was always, I did some data collection anyway, and then I had the geoscientist doing the referencing of the raw data, and then I received as an output geodata. The question is, isn't there some explicit form of georeference already in the raw data? Isn't it geodata as well? And here we have also a change in paradigms. In former times, in some domains still today, we had preprocessing centricity. So to get some kind of valuable geodata, we needed some preprocessing. Nowadays, we have a lot of real-time capacities. So georeferencing, spatial analysis is done in real time. There is no need for a geoinformation scientist doing some georeferencing. It's somewhere done by the system, automatically, by algorithms. To give you some examples where these points become critical with regard to understanding of geodata, look at indoor positioning. That's a classical application for geodata, the own position that we get through a system, but it's more than just the own position we get. We are working on signals. We are working on, for instance, Wi-Fi signals that have a spatial distribution. So the signal itself becomes some kind of geodata for us, how we interpret it. Or looking at some applications for autonomous driving where we are working on at the moment. If you take an autonomous car, in such a situation, getting here around a crossing at a traffic light, classical positioning services wouldn't be sufficient. Like GPS, plus minus 10 meters is not sufficient for an autonomous car to find here the right lane and orient itself. What are the ideas in automotive industry? Tagging, it's car to X communication. The car will communicate with some infrastructure points, for instance like RFID, UWB, as a communication way, frequencies that are used to transmit data where a signal is, or just to identify a signal and measure it. Which means each of these tags, also tags placed at cars. Cars will communicate with cars to exchange information about their current position, either at absolute one or as a relative one. Which means we are working with a huge amount of data, and we are working, especially in these new domains, with signals. And if we think now about the spatial reference characteristics of signals, then the information, first important one is that there is a signal. And maybe this signal, think on the RFID tag, has a position, if I can bring it together, then the existence of a signal is already geodata, if I process it. I can do a lot more on it. I can measure the field characteristics, I can calculate the travel times to calculate distances, I can identify directions. So you see we are in a domain quite similar to positioning. We are talking about the spatial characteristics of the signal. At the next step, I can identify the frequency, and through this I can work on the data, the message transmitted through the signal. And if I look then on the signal itself, I think you know about how Wi-Fi positioning is done. You identify some hotspot ID, which is some signal metadata hidden in the signal as a message. It's part of the message, but it's metadata. Then I have the message, which is your data you're already transferring at the moment through the Wi-Fi system. And then you have the message itself, that's the email you're currently sending, or your WhatsApp chat you're at the moment sending. So if I see this kind of data, there is a lot of data with a lot of spatial characteristics. And if I process it with regard to this spatial characteristic, from my perspective, this is already geodata. Because I'm talking about data and some kind of spatial reference. It's not the quality we have maybe through 100% perfect referenced spatial imagery, aerial images. It's a different quality because I maybe talk about directions or distances. Maybe I don't have the exact position of a moving car, I just have a relative position because it's 20 meters in front of me. But it's spatial data, it's geodata. So if I go now to the geodata definition, I think we have to get rid of some ideas and we have to redefine it. Because what it is about is data. Data is any form of thing we process, independent of it's stored or not. We refer to entities, not the landscape. It's located somewhere and some form of spatial reference is available. And what is important from my point of view is that it also can be derived. It does not have to be stored with the data itself. So if you take the idea of a shapefile where you have the attributes on the one hand side, the geometry on the other hand side, and the spatial reference in an absolute reference system, well, that's a high quality of geodata. But if I take, like the colleague showed, the data from the chimney sweeper, which is in the first way not georeferenced, but each building that is represented in this data has a spatial characteristic. Even if it's not stored in the Excel table that we receive, it's geodata. Because there is somewhere a way how to derive it. Data mining, big data, etc. I combine two data sets, and out of this I get new geodata. One data set with reference, one without. But if I'm able to match it, both, have some spatial meaning, which means it's geodata. And I will process it later on in a spatial context, so there must be a sense to use the spatial context. So this would be a suggestion for a new definition of geodata that considers also these new applications, sensor data, etc. Geodata is any kind of data about or from an object located in space. The sensor is an object in space that could provide spatial data. But the data has some kind of spatial characteristics, its position or some other form of spatial meaning, either stored directly with the data or through the potential to derive the spatial context. And where the data could be used, processed, considering this spatial context. Well, what does this approach mean towards geodata with regard to open data now? Well, the classical things in open data, how to make these files available, that I can download it, there is a license where I can access it, I can modify it, what open data means, will be still unmodified. But with regard to these new approaches, new questions appear. Because if I look on this signal data, then there comes this idea of openness in different ways. Because the existence of a signal is always open. If it's a wireless signal, it's always open. I can access it. That's how you can measure that there is a Wi-Fi network. And already about this knowledge, you know the criticism on Google driving through the streets, not only taking pictures for its street view service, but also on the second hand, measuring Wi-Fi hotspots. In Germany, there was a big discussion whether this approach is legal. From a technical perspective, the existence of a signal, of a wireless signal, is open. So, open accessibility from a technical point of view. The question now, yes, there is a public interest, because these signals, Wi-Fi signals, as already mentioned, are a contribution to improved positioning services. In contrast to GPS, I can do with Wi-Fi services, indoor or outdoor, plus minus 1 meter. Positioning precision, which means there is a public interest to use the signal, the information I have, that there is a signal, its position, where the source of the signal is, where the consequence could be that the existence of a signal is not only from a technical point of view open, accessible, but it should be also from a legal perspective an open data that there is a signal. Because on the other hand side, the signal itself, the frequency, is a public good. We can use the signal because the state granted us a license to do it. Otherwise there would be chaos. For signals there are granted licenses that you can operate a sender or a receiver. For Wi-Fi everybody can do it. For different types of signals you need specific licenses. Which means there is a public good character of the signal, there's a public interest and it's open accessible. That raises the question whether the existence of a signal and maybe also some of its characteristics, like the field that I need for positioning or other purposes, should be open geodata. The other issue is then here on the message itself, the question, is there a need for legal protection? How deep am I allowed to go? Am I allowed to identify the signal? Yes, I need, because otherwise I wouldn't have any Wi-Fi or GSM or what else. The direction, signal strength, I cannot avoid it from a technical perspective. I could only restrict it through a legal perspective. If I go into frequency, signal metadata, what is the name of the hotspot? This SSID, following things, there it gets critical. Because it's more about the message itself, the data that gets transmitted through the system, than the signal itself. And then we have the message data and the message metadata, where we have a strong need for legal protection and then also for partial or full technical protection, encryption standards, to avoid that the availability of the signal becomes a problem for data privacy. But as you see, with these new applications in geomatics, we get a problem with regard to the definition, what is geodata? I don't think that my definition of geodata, the new definition, is 100% perfect. And I would like to ask you to critically discuss it because my opinion is that we need a new definition of geodata. And in addition, we need, besides the classical approaches towards open geodata, also discussion about these new technologies, signal-based analysis, etc., whether we have here open geodata or not, and what this open character of this data, of these signals, means for its usability as open data or the necessities to restrict access. Thank you very much.